hertz, all the way up to into the megahertz, way past audio, way past even standard video. So this is these inputs have dual purpose inputs that can take two different types of signals on the same connector depending on the kind of cable that you use to connect. So they can take audio synthesizer type signals in the audio range. They can take video signals from my video modules. And both the audio synthesizer and my modules can create signals that are down below audio range down to DC, which is 0 hertz. So that's a signal that doesn't move at all, doesn't go up and down, it just stays at 1 voltage. And can, at above that, it can move extremely slowly. So you can have sub-audio signals that are moving, say, 1/10 of a hertz, like 1 cycle every 10 seconds. And then as you go faster, you get up into the audio range. And then as you go faster, you get past the audio range into the video range. And then that can keep going up to the top end of video and beyond. So these modules actually can accept signals up to well beyond the video range. But by the time they come out, the output amp, that limits it to the standard composite video range.
Okay.
Dave, sorry, quick question. Can you remind me the kind of cable that you use for patching video internally in this signal?
Yeah, all of these inputs, if you use a mono cable from a Eurorack system, it sees plus minus 5 volts on the tip of that mono cable. If you patch from the video outs on one of my video modules, you get plus minus 1 volt on the ring of a stereo 3.5 millimeter cable. And it goes into the same input on the same module, and that module is a stereo connector. So it sees either plus minus 5 on the tip or plus minus 1 volt on the ring, depending on whether you use a mono cable coming from a plus minus 5 source or a stereo cable coming from one of my video modules.
Excellent.
So if we patch, say, one of my oscillators into the output amp, and we crank this sucker down.
So is this the sine wave?
This is a sine wave.
Okay.
So if we take this down to sub-audio, we've now got a sine wave running at 1 cycle every, I'm not sure how many seconds here, every few seconds. So this is well below audio range. And it's just a control voltage that's going up and down at a fairly slow rate. The oscillators have a frequency control knob and a switch for coarse, medium, and fine. With the switch on coarse, you can fairly quickly move through all the frequencies to get to roughly the range that you want. And then you switch it to medium, and you can get then closer to the actual frequency you want. You go to fine, and then you fine tune in the exact frequency that you want. That way you, rather than have 2 knobs for coarse and fine, or a range switch to give you different ranges, it's 1 knob and a coarse, medium, and fine switch, and you can fairly quickly move through the whole range. The knob is a continuous turn, billion turn knob. It turn it as many times as you need to. So as we turn it up, you can see that the oscillator starts going into the flicker range, and then we start getting vertical rate bars. So now we're going at about 60 hertz because we've got 1 bar. And as we go up from there, when we get 2 bars, we're at twice the vertical rate. 3 bars, we're at 3 times. 4 bars, we're at 4 times. And so each time we go another multiple of the vertical rate, we get another bar. And we can keep going up and get more and more bars going side to side until we've gone a multiple of the vertical equal to how many scan lines there are.
And that's when it flips to...
And that's when it flips to horizontal. So eventually, the bars get so fine.
Mm-hmm. Do you get like a moire kind of thing happening, or does it do?
Well, and then we flip to horizontal. So now we've got 1 bar horizontal.
Okay.
So now we're running at 15,750 hertz or 15 kilohertz.
Uh-huh.
So now we're running at the horizontal rate. And as we go up from there, we get 2 bars, and then 3 bars, and 4 bars. And now this oscillator is free running. It's not being synchronized to the horizontal. So that's why they're going diagonally and rotating around at all these different angles.
Mm-hmm.
If we were